to do with how many different combinations you can make out of certain events. So if one event occurs p times, or p ways, and another event occurs q ways, then the total number of different combinations will be p times q. We'll do an example from the Snoopy. Just now.
So now you just multiply the different options.
Yeah. Okay, the next example, don't write everything down. Just write down the combinations like this. Example 1, we have 1, 2, 3, 4 starters. We have 1, 2, 3 main meals. And 1, 2, 3, 4 desserts. Don't write down what the desserts or the main meals or the starters are. So you just write that little block. Now the first question is, Jill goes to the cafeteria and she only wants a starter and a dessert. How many different combinations can she choose? A starter and a dessert.
16.
Yes. So for number 1, it will be 4 times 4, 16 combinations. Number 2, Jack goes to the cafeteria. He wants to order from all 3 courses, a starter, a main, and a dessert. How many different combinations can he choose from? 48. So it will be 4 starters times 3 meals times 4 desserts, and that is 48 different combinations. Do you agree? This is very easy. Okay. Now let's make it more interesting. Question 2. A password can consist of a number of letters and numbers. So if we have the format 3 x's, 2 y's, and an x, oops, excuse, where x is a letter and y is a number. Okay, how many letters do we get? 4. Nee man, nie in the password. In life. 26. How many numbers do we have? No. 10. From 0 till 9, 10 different numbers. Okay. Now we have to use these to make the password. If we can use identical letters and numbers, x represents a letter. how many letters can I put in the first place? How many?
26.
26. And in the second place, if I can reuse the same things, 26. And number 3, 26. Okay, now we get to numbers. How many numbers can I put here? 10. 1 of 10. Okay. And here, 10. Now we're back to letters, 26. So the number of possible combinations will be 26 times 26 times 26 times 10 times 10 times 26. A shorter way to write it will be 26 to the power of 1, 2, 3, 4 times 10 to the power of 2. And that will give us 45,697,600 combinations. Okay, do you understand?
Ma'am, you counted 0 as a number.
Yes.
Oh, so that's why it's 10.
Yeah.
And not 9.
Yeah. Now for question 2. Again, I'm going to write the password, but now we have to exclude the vowels. How many vowels do we have? 5. So how many letters do we have? 21. Okay. I'm just going to move this up. So for number 2, I still need 3 letters, 2 digits, and a letter. So my x's are 21, excluding all the vowels, and my y's still are 10. So in the place of x, it's 21, 21, 21, 10, 10, 21. If you multiply everything, it will be 21 to the power of 4 times 10 to the power of 2, and we get 100 possible combinations. Now for number 3. How many different passwords are possible if no number or letter may be repeated? So you can't use doubles. We start again with 3 x's, 2 y's, and an x. We're back to normal letters. So the x, we have 26 possibilities, and for y, we have 10 digits. We can't repeat. So if we choose from 26 for the first position, we can use 26 letters to choose one. Okay, I've taken one out of the bag and I put it in place. How many are left? 25. So for the second password digit, I can only use 25 letters. I take one out of the box, put it in place. How many are left? 24. So for the third digit of the password, I use 24. And for the last one, I use 23. Okay, now the letters are done. Let's look at the digits, the numbers. Anzile, how many can I use for the first Y? 10. And for the second Y? 9. So the combination will be 26 times 25 times 24. I'm going to put the 23 there, times 10 times 9. And that gives you 32292 combinations. No repeats. Everybody with me? Okay, your first homework piece. This homework is 2 lines. What? Page 288. Okay, can I carry on? Okay, now for the second half of the lesson. We're doing factorial notation. Factorial notation has to do with, let's say there are 5 children and they need to sit on 5 chairs. First, you pick 1 out of 5 to sit down. Then there are 4 left. So you pick 1 out of 4 to sit down. Then there are 3 left. And then 2. And then 1. So you multiply 5, 4, 3, 2, 1 with each other to get 120 combinations. And to write this, decreasing numbers down, we use a short way, 5 faculty. So 5 faculty means 5 times 4 times 3 times 2 times 1. And 0 faculty is always 1. Faculty is on your calculator. You use second function and it's there. Yes. So type in 5 faculty and see if you get 120. Good. Let's look at an example. A photographer places 6 chairs for 6 children, which 2 are boys, so 2 boys and 4 girls. He's going to take a photo of these children. If any child can sit in any chair, how many possible combinations will he have? There are 6 children. 2 boys, 4 girls. So, in chair 1, how many children can sit in chair 1? 1 of 6. And in chair 2, 5. And in chair 3, 4, etc. And this is the pattern for 6 faculty. So, 6 faculty equals 720 possible seatings.
Is that for number 1?
Yes, this is number 1. Now, the boys are difficult. They want to sit next to each other. So how many possible seatings do we have now? There are 2 boys. They want to sit next to each other. And the rest can sit wherever they want. So now, we have 6 chairs. Whoops. 6 chairs. Because the boys want to sit next to each other, we treat them as one person, as one unit. So now we have 1, 2, 3, 4, 5 possible way of arranging the children. Do you agree? The 2 boys sit next to each other, so we treat them as one object. Then that is 1, 2, 3, 4, 5 possible seatings. So it will be 5 faculty. Do you agree? So it will be 5 faculty, but the boys can also sit like this. So the boys have 2 faculty seatings. They can sit like this, or they can sit like this. So it's two ways. Therefore, the possible seatings will be 5 times 2 faculty. And that gives you 120 times 2, and that's 240 arrangements. Do you follow? These 2 boys, if we have 5 chairs, they can sit here. So the other 4 will be for the girls. Or they can sit here. So the other 4 will be for the girls. So we actually have 4 plus 1 arrangement. So it's 5 arrangements. But the boys on their own can swap. So we have 2 faculty for the boys only. Do you understand that? And then you just multiply them. 5 for the arrangements for the boys together with the rest of the girls, and 2 for only the boys.
Why do you say 5?
If the boys want to sit together, you treat them as a whole.
So we have to imagine that they're sitting on one chair.
They're sitting on 2 chairs, but they're a unit. So the boys is a unit, and the 4 girls. So it's the 4 girls and the boys as a unit. This is the 2 boys. They sit together. So they can either sit in front together. So we have 1, 2, 3, 4, 5 possible ways. Or they can sit here, and we have 1, 2, 3, 4, 5 possible ways. Or there, or there, or there. Okay. But they have to be together.
What happens to
the 2 faculty? The 2 faculty means that these 2 boys can either sit like this or like this.
number of Y's.
Okay. Let's look at number 2. A grade 12 learner has an accounting, science, Zulu, and maths textbook. How many different ways can this learner arrange the bookshelf? If he wants to place the accounting textbook, the science, the Zulu, and the mathematics textbook on the shelf, how many different ways can he arrange them? How many books are there? 4. So how many different ways? 4 faculty. 4 faculty, and that is 24. Okay, number 3. If you want to shuffle the word marks, letters, the letters of the word marks, in how many different arrangements can you shuffle it? 5 faculty by Moy. And that will be 120 different ways. Now, we get to a more interesting one. We have 2 different history books, 3 different geography books, and 2 different science books. We have to place them on a shelf. In how many different ways can they be arranged?
90 times 2 is 6. 8 or 6 times 2 is 12. And then just say 12.
Okay, there are 2 different history books, 3 different geography books, and 2 different science books. How many books are there altogether? 7. How many different arrangements can you make with those 7? 7 faculty. I didn't say that they have to be together, so it's only arrange them. 7 faculty equals 5040 arrangements. Now for number B. There are 7 books. 2 history, 3 geography, and 2 science. Remember I said we treat the groups as one unit. So there's a unit, there's a unit, and there's a unit. We only do that if I ask you the same subject must be placed together. So only if they ask you the boys must sit together or the books must stay together, then you treat them as units. So how many units do we have? 3 units. And how many ways can you arrange the 3 units? 3 faculties. So these are 3 faculties. How many ways can you arrange the 2 history books? 2 faculty. How many ways can you arrange the geography ones? 3 faculty. And the science ones? Okay. So what will our answer be, do you think? Yes. 2 faculty times 3 faculty times 2 faculty times 3 faculty. So it will be 2 faculty times 3 faculty times times 2 faculty times 3 faculty, and that will be 144. If you want to keep the history books together, and the geography books together, and the science books together. Okay, question 5 is a typical question for the exams and tests. Judah, are you awake? No, ma'am. In a school are 8 prefects, 5 girls and 3 boys. They are to be seated on a stage. So for question 1, in how many different ways can they be seated?
16.
8 prefects, 5 girls, 3 boys. 8 faculty. And that is 40,320 different ways. That's a lot. Now for question B. All the boys and all the girls want to be seated together. So boys together, girls together. We have 8 seats. We have 5 girls. 1, 2, 3, 4, 5. And 3 boys. They want to sit together, so we have units. 1 unit and 1 unit. How many different ways can these 2 units be arranged? 2 faculty. And the girls, how many ways? 5 faculty. And the boys? 3 faculty. So altogether it will be 5 faculty times 3 faculty times 2 faculty. And that will be 1,440. If all the boys sit together, shuffled, and all the girls sit together, shuffled. And we can shuffle the boys and the girls. Now for number C. If the prefects are randomly seated, what is the probability? Now we get to probabilities together with faculties. What is the probability of all the boys and girls being seated next to each other? In other words, the boys together and the girls together. So for number C, we want the probability of boys together and girls together. What will that be? It will be the faculty of boys, girls, so it will be 1440 over the total 4320. And that gives you 1 over 28, which is 3,567. Yeah.
And we must have the 4032. I understand 8 faculties, I added as well as the 8 prefects, I understand that part. But then now, why are we multiplying the 2 faculties on both the beams as well with the 5 faculties? Why don't we just say 5 faculties times 3 faculties, right?
Because these 2 groups can also be shuffled. They can sit like this, or they can sit like this. So there are 2 ways to do that.
Yes.
Okay.
Ma'am, could you re-explain A now? I don't understand.
A. There are 8 prefects. 5 girls, 3 boys. So how many ways can you 8 faculties.